Hello everyone, this is Salma Shabnam, Department of Mathematics, St. Joseph Engineering College, Mangaluru. In my last video on sampling theory part 2, we have discussed procedures on testing of hypothesis to decide whether to accept or reject the hypothesis. Here we take a quick scan on how to make a decision on to reject or accept the null hypothesis. We have two types of tests here: two-tailed test or and one-tailed test. At 95% confidence level or 5% level of significance, the critical level value is given, ZC is given by 1.96, and the confidence interval is ranges between minus 1.96 to plus 1.96. The confidence limits for the means is given by x bar plus or minus 1.96 sigma by root n, where x bar is the sample mean, sigma is the population standard deviation, and n is the sample size. For 99 level of significance, the critical value is ZC, and the confidence limits for means is given by x bar plus or minus ZC value is 2.58 into sigma by root n. So we first formulate the null hypothesis and then find out the Z score or the Z statistic given by x bar minus mu x bar by sigma x bar. So here x bar is a sample mean, and mu x bar is same as the population mean for the sample distribution of means, and sigma x bar we know is sigma by root n for sampling distribution of means, where sigma is the population standard deviation, n is the sample size. For two-tailed test, if the calculated value of Z or Z score falls inside the interval or acceptance interval, that is minus 1.96 to plus 1.96 for 95% confidence level or 5% level of significance, we accept the hypothesis. If the Z value falls in the critical region, that is outside the above interval, then you reject the hypothesis. The same is the case when it is 99% confidence level or 1% level of significance. The acceptance region is minus 2.58 to plus 2.58. In the case of one-tailed test, if the Z score is more than 1.645, then Z falls in the critical region for 5% level of significance. For 1% level of significance, the Z score, if the Z score falls if the Z score falls in the critical region, that is, if the Z score is more than 2.33, then Z falls in the critical region, then we reject the hypothesis. In the left tail test, if at all the Z score is less than minus 1.645, then Z falls in the critical region, we reject the hypothesis. Same is the case when Z is less in, for the case of 99% confidence level, when Z is less than minus 2.33, then you reject the hypothesis. To test the sampling distribution of difference of means, this statistic or the Z score is given by x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2. Here x1 and x2 bar are nothing but the sample means of the two samples picked up from two different populations or can be from the same population, and sigma 1 and sigma 2 are the standard deviations of the two populations from which the samples are picked up, and n1 and n2 are nothing but the sample sizes. For the Z score of sampling distribution of attributes or sampling of proportions, the Z statistic is given by x bar minus np by root npq. We have few examples here for the better understanding of testing of hypothesis. The first one is: a coin was tossed 400 times and the head turns up 216 times. Test the hypothesis that the coin is unbiased at 5% level of significance. So first we need to keep in mind that the null hypothesis is always the neutral statement. It never takes sides. So if you have to take the null hypothesis for this particular problem, then we take the null hypothesis as yes, the coin is unbiased or the coin is fair. So for that case, when the coin is fair, the probability of success that the head falls is p is equal to half. So obviously q becomes half again because they have equal chances of falling. So the expected number of success happens to be n into p in this case, where n is 400, so we get it as 200. So the practically or the observed value of the successes. So in the experiment we see that the number of times the head falls is 216, therefore the observed value is 216. So the statistic is given by x bar minus np by root npq. Substituting the above values here, we get it as 1.6, and we observe that 1.6 is strictly less than 1.96, therefore it falls in the acceptance region. The z-score falls in the acceptance region, therefore we accept the hypothesis as the coin is unbiased. The next example we have here is a manufacturer claims that at least 95% of the equipment which he supplied to a factory conformed to specifications. An examination of a sample of 200 pieces of equipment revealed that 18 of them were faulty. Test his claim at a significance level of 1% and 5%. So here the claim of the manufacturer is at least 95% of the equipment is according to the specifications. Therefore, we accept the hypothesis what the manufacturer claims. So we say that the claim is true. So when you take the claim is true, the probability that the equipments are according to the specifications is 95%. Therefore, the probability of success P is taken as 95%, or 95 by 100 is 0.95. So we take the claim as P is equal to 0.95. In order to accept whether P is the claim is true, we we calculate the z statistic. Then for that we need to know what is NP. NP is, that is nothing but the mu mean, is n into p, where n is how many 200 and p is 0.95, we get it as 190. Sigma is root npq, we get it as 3.382. So for the z statistic we need what is x bar. X bar is nothing but the observed value. The observed value is nothing but among 200 pieces we have 18 of them being faulty, therefore the remaining 182 pieces are according to the specifications, therefore the observed number will be 182. So z score happens to be minus 2.6. So since we know that if at all the claim is incorrect, then the probability must be less than 95%. That means to say less than 95% of the specific the equipments must be may be according to the specification. Therefore, since P is less than 0.95, it covers the left hand side of the normal curve, or one side of the normal curve. So we prefer to choose one tail test in this case. Therefore, according to the left tail test, at 5% level of significance, we see that minus 2.6 is less than minus 1.645, therefore is in the critical region, therefore you reject the hypothesis. Also in the 1% level of significance, minus 2.6 is less than minus 2.33, the calculated value of z is in the critical region, therefore in this case too we reject the hypothesis. The next example we have here is, it has been found from the experience that the mean breaking strength of a particular brand of thread is 275.6 grams with standard deviation of 39.7 grams. Recently, a sample of 36 pieces of thread showed a mean breaking strength of 253.2 grams. Can we conclude at a significance level of 5% and 1% that the thread has become inferior? So here the claim is that thread has become inferior, but we know that the null statement does not take sides, it is a neutral statement. Therefore we say that the mean breaking strength of the thread remains unchanged. That means to say the mean breaking strength is same as 275.6. Therefore the mean breaking strength is nothing but mu, because it's a mean. Therefore mu is equal to 275.6 grams. So we take the H naught as mu is equal to 275.6 grams. If at all this doesn't is null hypothesis happens to be false, then the alternate hypothesis has to be what is being claimed. That is the thread, the mean breaking strength of the thread has to be less than 275.6. Then it becomes inferior. So we take that the alternate statement is mu is less than 275.6. So therefore, because this statement, the alternate statements again specifies only one side of the normal curve, we want to take one tail test here. So taking the z statistic, we see that x bar is mu x bar minus mu x bar by sigma x bar, where mu x bar is same as the population mean, that is 275.6, and x bar, when we look into the statement, we see that 36 pieces have mean breaking strength of 253.2 grams. So x bar is 253.2 grams, and sigma is for the population is 39.7, and we get it as z statistic as minus 3.38. So at the 5% level of significance, we see that minus 3.38 lies in the critical region. It is less than minus 1.645. And also for 1% level of significance, minus 3.38 also falls in the critical region, which is less than minus 2.33. Therefore, we reject the hypothesis in this case, and we say that the mean breaking strength of the thread is inferior. The next example we have here is in an examination given to the students at a large number of different schools. The mean grade was 74.5 and the standard deviation grade was 8. At one particular school where 200 students took the examination, the mean grade was 75.9. Discuss the significance of the results from the viewpoint of one-tail test and two-tail test at 5% level of significance. So we can take that the null hypothesis as the mean grade of the students is 74.5. It is same as 74.5. We accept that. So that if at all it is to be false, if the null hypothesis is to be false, then the mean grade has to be less than 74.5 or can be greater than 74.5, because it is not mentioned. So it can take both cases. So we have the alternate hypothesis. If mean grade is not equal to 74.5, then it is either less than 74.5 or greater than 74.5. So with this in mind, taking the H naught that mu is 74.5, we take the Z statistic as x bar minus mu x bar by sigma by root n. X bar for the sample is mean grade is 75.9. Mu x bar is same as mu, so 74.5, and sigma is 8 divided by root 200. So we get it as 2.475. So in the case of one-tail test, we see that at 5% level of significance, we see that 2.475 is greater than 1.645. Therefore, it falls in the critical region. We reject the hypothesis. In case of two-tail test, we see that 2.475 is also greater than 1.96, and therefore falls in the critical region. We reject the hypothesis. So next example here we have is in an elementary school examination, the mean grade of 32 boys was 72 with the standard deviation of 8, while the mean grade of 36 girls was 75 with a standard deviation of 6. This is the hypothesis that the performance of the girls is better than boys. In this, the claim is performance of the girls is better than boys is given. Therefore, we take the null hypothesis as a neutral statement. That is, there is no difference in the performance. That is, the mean grade of the girls and the boys are the same. So mu1 is the mean grade of performance of the boys, and mean grade of the performance of the girls is mu2. So mu1 is same as mu2. That will be the neutral statement, H naught. So with that in mind, we see that x1 bar is 72 for boys, and sample size is 32, and the standard deviation for boys is 8. The second population is of the girls, so x2 bar is 75, n2 is 36, and the standard deviation sigma 2 is 6. So using the Z statistic with the following formula, we get it as minus 1.73. So we see that minus 1.73 at 5% level of significance, because the claim is the performance of the girls is better than boys. We have to test this hypothesis. It is nothing but mu1 is less than mu2. It is one side of the normal curve. So we prefer to use one-tailed test here. So using one-tailed test, we see that Z is equal to minus 1.73. The calculated value falls in the critical region for Z plus 5% level of significance. 1.73 is less than minus 1.645. So in this case, we reject the hypothesis. In the case of 1% level of significance, we see that minus 1.73 is greater than minus 2.33. It falls in the acceptance region. Therefore, we accept the hypothesis at 1% level of significance. So the next example we have here is the mean of two samples of 1000 and 2000 members are 168.75 and 170 centimeters. Can the samples be regarded as drawn from the same population of standard deviation 6.25 centimeters? So here we have to check whether the samples are drawn from the same population. So we accept that hypothesis. We regard that the two samples are drawn from the same population. Therefore, sigma of the standard deviation of the population is 6.25. So we accept that. So proceeding in that matter, we see that x1 bar is 168.75, x2 bar is 170. N1 is 1000, N2 is 2000. So Z score happened with this Z score and sigma, because we regard that the two samples are drawn from the same population, sigma 1 and sigma 2 is 6.25. So the Z score happens to be minus 5.16. Keeping in mind sigma 1 and sigma 2 are the same. So minus 5.16 lies in the critical region. It is less than minus 1.56 for 5% level of significance, and also it is less than minus 2.58 at 1% level of significance. Therefore, both the Z falls in the critical region for both the cases. We reject the hypothesis and we say that the samples cannot be drawn from the same population. Now, the last example we have here is a random sample of 1000 workers in a company has mean wages rupees 50 per day and standard deviation of rupees 15. Another sample of 1500 workers from another company has mean wage of rupees 45 per day and standard deviation of rupees 20. Thus the mean rate of wages varies between the two companies. Find 95% confidence limits for the difference of the mean wages of the population of the two companies. We see that the first case, we have the first sample, the mean x1 bar is 50 and standard deviation sigma 1 is 15 and n1 is 1000. In the second sample, we have mean x2 bar is 45 and standard deviation is 20, and n2, the sample size is 1500. So the null hypothesis we formulate here is the mean rate of the two companies, it has to be neutral. Therefore, we formulate the null hypothesis as there is no difference between the mean rate of the wages of the two companies. So mu1 is same as mu2. therefore we have x1 bar minus x2 bar by sigma 1 square by n1 plus sigma 2 square by n2. Substituting the values, we get z score as 7.13. We see that the z score falls in the critical region for both the cases at 5% level and 1% level. Therefore we reject the hypothesis and we say that there is a difference between the mean wages. The 95% confidence limits is given by x1 bar minus x2 bar plus or minus 1.96 into root of sigma 1 square by n1 plus sigma 2 square by n2. Substituting the values, we get 5 plus or minus 1.374. When we add, we get the upper limit of the interval. When we subtract this value, we get the lower limit of the interval. Therefore, we see that at 95% confidence, the difference between the population of the mean wages varies between rupees 3.60 to 6.37. With this, we have covered all the types of examples for testing of hypothesis. Thank you. Happy learning.